Let's look at some examples from the probability section 12.2. This first question says, one card is selected at random from a deck of cards. Determine the probability that the card selected is a 7. So the probability that the card selected is a 7 is, and we're going to write our answer as either an integer or a fraction. So the first thing we want to look at in determining probability is the number of outcomes that are favorable to E, or the event, divided by the total number of outcomes. So we want to see it would be considered a success or favorable to E if we drew a 7. How many 7s are in a deck of cards? We know that there are 4 in a complete deck. So there would be 4 outcomes favorable to E over the total number of outcomes, which there are 52 possible cards in the deck of cards. Now this is not a simplified fraction, so we do want to cancel out any common factors. Both 4 and 52 have a common factor of 4. So if we rewrite the numerator as 4 times 1 and the denominator as 4 times 13, we could then cancel out the common factor of 4, and we're left with the simplified fraction 1 over 13. Also, using your calculator, if we were to use the calculator and type in 4 divided by 52, press enter, that would give me the decimal equivalent. And then if I wanted to see the fraction in its most simplified form, we have a button here that if I press second and then table, you see this up above, it's fraction changed to decimal or changed back to fraction. So I typed second, typed that button, press enter, it's going to change it to the simplified fraction 1 over 13, which is what we got to begin with. Let's look at this next problem, still in section 12.2. What is the probability of getting either a jack or a 2 when drawing a single card from a deck of 52 cards? And it is important for some of the problems that we're going to do in some later sections that we definitely note that we're only drawing one card from a deck of 52 cards. So to find the probability that it's either a jack or a 2, we need to look to see again what is the number of favorable outcomes for this event, and then we want to know the total number of outcomes. So for it to be a success or a favorable outcome, we would either need to draw a jack or a 2. And how many jacks are in a deck of cards? We know that there are 4 jacks. There would also be 4 2s. So the total number of favorable outcomes would be 4 plus 4, which is 8. We'll write that over the total number of outcomes, which is again our deck of cards, so every card is considered an outcome when we draw a card. So that would be out of 52. Now that's not a simplified fraction, and we've been told to write it as a simplified answer. So I can either cancel out a common factor. The common factor between 8 and 52 is 4. So if I rewrote this as 4 times 2, 52 is 4 times 13, and canceled out the common factor of 4, I'd be left with probability as 2/13. You could also on your calculator type in 8 divided by 52. If I press enter, that's going to be the decimal form of that fraction. But then if I convert it back to fraction form, it will give me the simplified fraction. So second, if I change it to a fraction, it's the second function of this table key. Press enter, and it gives me 2/13, which is the probability that we would draw either a jack or a 2 on one single draw. On the next example, it says you are dealt one card from a standard 52 card deck. Find the probability of being dealt a queen and a 10. Now this one does not say a queen or a 10, so for it to be a success we would have to have the card be both a queen and a 10, and remember that it's only one card. So would any card fit that definition, that it would be both a queen and a 10, when we know that that's not possible? So there are 0 favorable outcomes out of a total number of 52 outcomes, which still obviously leaves me with 0 as the probability of being dealt both a queen and a 10 on only one card being dealt. In the next problem, we're given that if the probability that an event does not occur is 0.055, then what is the probability that the event occurs? And we'll use the fact that the probability of A plus the probability of not being A is equal to 1. We're going to fill in what we know. The probability the event does not occur is the 0.055. So the probability of A plus 0.055 would add to be 1. And since probability of A is unknown, so that we solve for probability of A, we would subtract 0.055 from both sides of your equation. In your calculator, we could type in 1 minus 0.055. So 1 minus 0.055 would give me 0.945. So the probability the event occurs is 0.945. On this problem, let's refer to the table. It shows the type of manufacturer of vehicles at a specific car dealership. If one person selects a vehicle at random from the dealership, determine the probability the person selects a car. So the number of favorable outcomes for this event, we would look at if they select a car. That would be considered a success. So what is the total number of cars? The total number of cars would be 76 out of a total number of vehicles, which is 125. Then we can check to see if there's a common factor between 76 and 125. If you're not certain, nothing really jumps out immediately because both of them are not even. This has a factor of 5, but 76 does not. Then we can use our calculator. 76 divided by 125. Here we have the decimal form, and then if we change that back to a fraction, it should give us the reduced fraction. And notice that the simplified fraction does stay at 76 over 125. For this problem, we have that a dart lands at random on the board shown. Find the probability the dart will land on a specified color. And we're first going to find the probability that it would land on a red square. Now the way that these are divided up, they're not equally likely to be chosen. So we want to look at these in equal parts. So as you're looking at rectangles and squares, they would need to have the same area, the parts that we divided into. So I can either look at this in parts, in 6 equal parts. This would be 1, 2, 3, 4, 5, 6, and each of those is the same size, and they would have an equally likely chance of being chosen. Or if we need to, we can divide it into smaller parts I can divide it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. So let's try to look at this one first by looking at it in 6 parts. So if I want to know the probability that the dart would land on a specified color, I have this part that's yellow, this part that's red, red, yellow, yellow, and blue. And those all have equally likely chance of being chosen, the larger rectangles. So out of the 6 larger rectangles, 2 of those are red. So 2 out of the total of 6 are red, which would mean that 1 out of every 3 is red once we simplified that fraction. I could do the same thing if I looked for what is the probability that the dart would land on yellow. And if I look at these 6 equal parts, 3 out of the 6 rectangles is yellow, which would leave 1/2 of them being yellow. And your probability that the dart would land on yellow would be 1/2. What about the probability it would land on blue? We have 1 rectangle out of the total of 6 larger ones that is blue. So 1/6 would be the probability the dart would land on blue.